Hello, everybody. Welcome back to our podcast. I think this is our fifth one, Derek. Fifth one? You did 10.
I mean, 5 times 2. I mean, there's 2 of us, so I don't know.
True.
5, yes, correct.
Thank you for joining us. I'm coming to you from Orlando, Florida, and Derek is in Melbourne.
I'm in Melbourne, that's right.
Today we have a really cool show planned for you. I'm going to be the customer today, and Derek will be the injection molding expert, right, Derek?
Yes, I will be today's injection molding expert, and that's going to be me.
Cool. So, Derek, I have this amazing product. It's just a piece of plastic.
Mm-hmm.
I have no idea, anything about anything. It's this thing here. I don't know. I think it's a shaver. I don't know where this came from, actually.
I know exactly where that came from.
we don't have to tell anybody what it is really. But I found, I have this idea I've been working on, and I don't know how to, what do I do? I want to sell 1 million of these things. How do I, what's the process? How do I do that?
Okay, definitely. So let me take a look at that. Okay, yeah, I know what that is. That is plastic, and by the looks of it, it's injection molded. And not only is it injection molded, it looks like it has some sort of chrome plating or some sort of plating. Yeah, that's the one right there. And it's designed in 2 different pieces. Okay, yeah, so I'm going to say that one right there is injection molded. So the first thing we're going to need to do is we're going to need a design. And let me give you a heads up. We're going to go through a couple of different steps here. We're going to need a design, we're going to need a prototype, and then we're going to need injection mold. And then for you, you're going to add a 4th step. That's going to be post-processing. That's going to be the chrome plating. So the first thing we're going to take a look at and what you're going to need to do is you're going to need a design. Jay, do you have a design of that thing in your hand there?
No, I just threw it together, really.
Mm-hmm.
I have no idea how I made this, but yeah.
So you basically, you want to have that made, but you don't have designs for it. Is that correct?
Yeah, I think I have 99 questions for you today about how do I actually make this. So I guess the first thing is what's injection molding?
Yeah, so injection molding is, and I'll probably roll over here, but injection molding is the form of making a tool, and a tool is an injection molding, several different items that go together, and we'll make a tool, and that tool will allow you to squirt injection molding hot plastic material inside of the injection molding tool into the cavity, and it'll allow you to make an actual part. So injection molding, it's a manufacturing method to squirt plastic into metal cavities and ultimately at the end of it, make a part for you when it cools down.
Got it. So you have to make a tool for me. So what is this tool? Is it a really big tool? Is it a small tool?
Yeah, exactly. Good question. So I'm hoping on the screen right now, you're able to see a picture of this tool, and the tools are highly complex. They're very big. They can be small, and they weigh several pounds, like say 50 pounds to several hundred, or even several thousand pounds. It really just depends on the size of the product that you're going to be making. So inside the injection mold, you have an injection molding, it's a mold core. So you have a big square mold base, and inside that mold base, you have these injection molding cores. And ideally, you're going to have different cavities inside each injection molding core. And those cavities are what is going to get filled up with the liquid plastic. That plastic, when it comes in, it's going to be in a liquid form. It's going to quickly cool down. And then eventually it's going to open back up and it's going to pop out the plastic. That plastic's going to fall down and it's going to come back together. So the question you had is, what's an injection mold? And the best I can do is explaining what's on the screen here, which is this big, huge injection molding base and molding core coming together.
Okay. So basically I have to design the product and then I can give it to you. You can design the mold, mm-hmm. and then we can manufacture it.
Yes, so exactly. Before you get into manufacturing, you need to have the part designed. And the part is designed using 3D CAD files. The software that we use, the 3D CAD software we use, is SolidWorks. And every year there's a new revision, that comes with the year. But there are many different free softwares online that you can use too if you're trying to do the design yourself. And you need to come up with the design of the part or the product itself. And I think we might be able to show something on the screen of a 3D CAD design of a product just kind of rotating. And that's the first thing you need to do. You need to have the part designed. Once you have the part designed, you need to then make a prototype of that part. And there are many different methods of making a prototype for these different parts. Most commonly today are 3D printed prototypes. And that is the process of, you want me to kind of go into the process of prototyping and what it means to bring a part?
I don't know. You're overwhelming me. You're just
Okay.
going too fast. I have like so
Okay.
many questions for you. So,
Sure.
okay. So design. So,
Mhm.
how did you know that this was injection molded? Like, how did you know?
Sure.
Aren't there like other ways to make this?
Yeah, there are actually several different ways to make it. But for me, when I take a look at that part, there are several indicators that identify to me that that part was injection molding. The first thing I do is I take a look at the thickness. How thick is that part? And if it's overall 5 millimeters or less, if it's thinner, then that's a pretty good indication that it was injection molded. So I see all the walls are pretty thin there. If you were to crack that open and break it open, you would see on the inside, you have these little kind of pin marks. And I'm not sure if you're able to see my screen, but on my screen here, you see this round circle?
Mm-hmm.
See that round circle? And see this round circle here?
Yeah,
Right
I can
there?
see it.
Those
Okay.
are what are in red up here. These are called ejector pins. So those are pretty good indications that this was injection molded. The part is thin enough and it was actually injection molded, and then the ejector pins pushed it out of the actual mold, and then it fell to the ground.
Mhm.
So those ejector pins are little pins that you see are pushing it out of the mold once it's hardened a little bit.
Got it.
And so for me to identify part, I can see part lines. And oftentimes, if you look close enough, you can find a gate location of where the plastic was actually inserted into the injection mold. And typically that's a little scar. I'm trying to look. Typically it's a little scar. So maybe right here, if you're able to see, can we get that in focus? So there might be a little scar of where the plastic is entered into the injection mold, and that would be the gate location. So plastic comes in, it fills the cavity, and then it goes all around. And then there's a whole part line going all the way around every single plastic part. And so the gate location, the ejector pins, these all kind of play into what is an injection molded part. And those are all kind of products of injection molding. You're going to have these kind of scars and marks left on the plastic. And then also you can see that this one is actually made out of PC ABS plastic.
Got it. So basically, if I grab a part and I open it, I can pretty much look for these marks and figure out, okay, yeah, this was definitely injection molded, and probably the part I'm making, if it's something similar, I could pretty much bank on it being injection molded.
Yeah, exactly. Now, I think if you're taking a look at, for example, an Apple product, and it's probably hard to see this because it's so glossy, but the point is they do such a really good job at hiding their ejector pins. They hide the gate location. They hide all of the blemishes that would occur. They hide everything in their design. So they're very smart and very clever about how they design their products. Whereas other customers, they're just trying to get parts done quick and get it out the door. They don't care if there's a blemish on the outside of the surface. So, it really just depends when you're designing for manufacturing and designing the parts, how everything gets laid out in the injection mold.
Okay.
Yeah.
So I hired someone to be honest with you. I hired someone from my university to help me design this, and he just, I don't even know what software he used. He designed it. He made this for me. Is this injection moldable, like the way it is? Can I injection mold it?
So there are many different, concepts and practices that go into plastic parts that are injection molded. And one thing I would do is I would take a look at several different items, and those items would help to identify whether it's designed correctly for manufacturing. Now, hear me out. Let me explain this a little bit. You might be able to design a part and you might be able to 3D print it, but that does not actually mean that you're going to be able to injection mold it. Picture this. Picture you want to make some ice cubes in an ice tray. And when you pour the ice in, it's liquid form. And when it hardens, it's a solid form. And if you wanted to get the ice cubes out of the ice tray, you're going to crack it open, and then they're going to be in this kind of shape here. And that makes it easy. That's called a draft angle. That makes it easy for that ice cube to be pulled out of the ice tray, right? So if there are not draft angles on your part, if it's straight up and down, trying to pull that piece out of the mold, it's going to have kind of this vacuum where it gets stuck in the mold, and it could even cause additional defects depending on the plastic design itself. So just because you hired the kid at the university to design the part, that doesn't mean that it was actually designed correctly for manufacturing. And the point is, we have a lot of customers come to us with different designs that, hey, I've already got it done. I have my prototype, just manufacture it. But the point is, we might actually have to go back and make revisions where we are shelling out the parts so they're hollow. We might have to change the draft angles. We might have to change some of the corners so they're not so sharp. There's a lot of practice and a lot of principle that goes into design for manufacturing to make sure that when it's manufactured, it's efficient, and efficient means saving money for you, and it means speed.
Got it. And you mentioned some design tools. So you said SolidWorks. Is that the best tool? Is that what I should ask people to use?
It doesn't matter the software itself. It comes down to the actual experience of the individual designing the part itself. There is Autodesk has a software. Again, there are various free softwares online. But I think if someone is using a free software, that indicates to me that they're probably novice. They're probably just getting started, and they might not know how to design best for manufacturing. So it's kind of an indicator when people are using kind of the free softwares that's not the best software. If someone is using SolidWorks or they're using the Autodesk, I think it's Inventor, if they're using those softwares or even Autodesk Fusion 360, it's kind of an indication that they probably know what they're doing, but it's not always a guarantee. And keep in mind, each one of those files that comes from SolidWorks or the Autodesk, they have their native format. So when you export it, it's kind of like exporting a generic file. I want what's called an STP or an STEP file, a step file. And I'm able to take those step files and we're able to evaluate the volume of the material. We're able to take a look at the surface area. We're able to take a look at the part geometry as well. And that's really important. So when you're manufacturing with or designing with any of those softwares, you're going to export an STP file. And that's what you're going to share to the manufacturer.
Got it.
Yeah.
Okay, so basically they'll design it. I'll ask them for an STP file. I can give it to you, and you can design the mold and start manufacturing.
Correct. And a lot of people, they think that once you start injection molding, it just goes. But that's not always true. You have to design that mold. And that mold, there's a little bit of wizardry and black magic that goes into designing these molds as well.
Got it. And just quickly, I mean, you mentioned prototyping. How do I prototype this design that I have someone else make for me?
Yeah, so there are companies that offer 3D printing services. You could also do kind of a CNC. So you have what's called additive manufacturing. That's where you have a plate, and a 3D printer will place it layer by layer. It will lay molten plastic on top, and it actually builds up into whatever shape your product is. Then you have what's called subtractive manufacturing. That's the CNC, where you start with a block, like a cube of plastic, and the CNC machine goes and it cuts just a little bit by a little bit, and it goes by in circles and passes, and it slowly cuts out your part and it subtracts away the plastic. So that's a second way. Another way is what's called RTV. It's basically you have silicone. So if I have a part, let's say this is my part, I can build a little box, put it in here, and I could pour silicone around it, and I could actually make a two-part silicone mold. I could pour resin inside, and I could also make a prototype that way. I think those are the three main, most popular ways of making prototypes.
Got it. So, I mean, do I have to make a mold? Can't we just 3D print 1,000 of these?
You could 3D print 1,000 of them. It really just depends on what you're trying to accomplish. Genuinely, there's a break-even point of cost and speed. And so you would know best what you're trying to achieve. You could most definitely 3D print 1,000 of them. It would probably take a little time, but you're also going to be sacrificing the quality. You're going to have little ribs or little lines on the part itself. Structurally, it's not going to be as strong as an injection molded plastic piece either.
Got it. Okay, well, so I got a prototype. I'm happy with it. Cool. I've used it. I've given it to some friends. They like it. I'm ready to manufacture. How do I, can we talk about materials? What material do I use?
Yeah, definitely. So the material itself, it really depends on several different factors, but we have to really take a look at the part itself and what is it being used for? Because there are plastic materials, then we have what are called additives. So if you're doing a plastic part that's going to be outside, we might want to add a UV additive to the plastic so that it's going to hold up a little bit longer in the UV light. Or if you're going to be doing fire testing, or you have something inside and it has to hold up to an ASTM standard, like for construction materials, we might add a different inhibitor there to prevent the flammability. So you have additives, but getting back to the plastics, there are thousands of different plastics. Traditionally, we work with several most common plastics, which would be like polycarbonate, PC, ABS, polypropylene. Those are the most common plastics. And then, of course, there is PVC, HDPE. Those are really the most common plastics. But what we see every day, ABS, polypropylene, and polycarbonate.
And is there like a way to pick it? Like, is there a table or something I can reference?
Yes. So there are tables online to reference. We also have created a little chart that kind of identifies a selector tool, which is kind of the best practice, but it doesn't guarantee that it is the best use case for you. So you kind of have to look through it and then talk through with the manufacturer or talk through with us even, and we'll help kind of guide you and coach you along the way of what material you need. For example, if you're going to be making lenses, you're going to be looking at two materials, PMMA or PC. So each material has kind of its own main, pros and cons. Like, why would I use this material over this material? If you're going to make a diffuser for a light, you're going to have a different material. If you're making a camera case or a case for electronics, for example, then it's also going to be a different type of plastic. So it's really important to communicate with the manufacturer what you're trying to do. We're not trying to be invasive. We're not trying to copy your project. We're simply trying to make sure that we have selected the right product, right plastic for your project.
Got it. Okay. So I think that makes sense. So I talked to you about this. You told me, hey, let's do ABS. It fits, my use case. Where does that happen? Like, where do we make them, or where do you make the mold, or how does that work? And where are my plastics coming from? Like, where do you make that?
Yeah.
And just a little bit about manufacturing.
Yeah, definitely. So we actually do have an office. We have our own office in Shenzhen in China. And a lot of different things can happen depending on who you are and what your product is. I think 100% of people, when they first come to us, they say, hey guys, I want to make my product in America. And we say, okay, cool, let's do it. And then once we go through the design stage, and then once we give them the quote, they kind of, they scratch their head a little bit and they say, can we do this? Can we save on money? And then typically when they want to save on money, that's when we do it in Shenzhen. And I think to this date, we have only imported a couple of different injection molds into the US and manufacture for customers. So the answer to your question is we do a lot of injection mold tooling overseas. Even the manufacturers that are manufacturing here in America, they're making the injection molds overseas and then they're shipping them by boat. Here, they're putting them in the injection molding presses in their factory. And then at that point, they're making them in the United States. Now, that's not a guarantee, but that is an overwhelming majority of injection molding factories here in the United States. Tools are made overseas, and then they're shipped here. But what we typically do is we make the tools overseas and the plastics overseas because the labor is a little bit more affordable, and then we ship them over here. Including, we'll make injection molds and send it to Nigeria. We'll make injection molds and send it to India, make injection molds, and even send them to Mexico. So it's very common to make them in China. But overall, we do the molds in China. And expensive is relative, right? That really just depends on the product that you're making. And there are two main items I would say that drive up the cost of an injection mold. The bigger they go, the more expensive they get, and also the more complex they go. So if you have something super small and intricate, or it has different angles and different geometry, making it more complex, then that's going to drive the cost up of the injection mold to be a little bit more expensive.
What should I be looking for? Like, what geometries are more difficult to make, and what are more simple? Yeah,
that's a good point. So I want to go back to the ice cube analogy. So when you're making ice in an ice tray, if a part, if you can pull it straight out, that's probably the easiest that you're going to have. It's basically a straight pull. So the plastic goes in and it comes out of the mold, and it works really easily. Once you start incorporating different angles where you have to have kind of unlocking tools, like it comes down here, it unlocks, and then it allows the plastic to open up, that's going to make it a little bit more challenging. It adds moving parts to the injection mold. Along with the moving parts goes higher prices. So if the part is able to come out easier, then it's going to be much cheaper to make.
Great. So Derek, I'm ready. I'm ready to make 1,000 pieces. I got the file. Can we do it? Can you give me 1,000 next week?
Yeah, let's go. Next week is a no-go. I can't do it next week, but I could probably do a couple things to get it going quicker. And actually, I'm going to let you in on some tips and secrets that I have. Are you okay with that?
Yeah, for sure.
Okay. So not everybody wants to tell you this, but if you go to an injection molding company, you can buy the brand new injection mold. And inside those injection molds are the mold cores. Now, we have used, and it's very uncommon, but we have been able to take an injection molding base, open it up, take the mold cores out, throw them away, get new mold cores, CNC them to the shape of your cavity, and put those into the injection mold, and then close it up. And we're able to take a used mold base and put brand new mold cores in there and make the product for you. So that is kind of a tip and trick that you won't hear anywhere that we could actually do. Now, it's very uncommon to do that because you can't do it very many times. The ejector pins, you have to drill holes in the backside, and it kind of starts looking like Swiss cheese. And you can only drill so many holes until that Swiss cheese is kind of like one big oblong, weird shaped hole in the back. So that's one kind of tip that we could do. And that will actually get you to where you need to go faster. But you're also having to sacrifice. You won't be able to like export that mold. That mold is going to be stuck at that same location. Another item that we could do is we could put different little valves on the inside of the injection molding core so that on one side of the mold, we could do ABS. And on the other side of the mold, we could do like polycarbonate. And that's just a little valve that can be inserted into the injection mold. It's common, oxymoron, I get it, but it's also uncommon to do that because the injection molder, they really want to make two different injection molds at that point, and they want to sell you two different injection molds. But if you know to ask for a valve that switches between the different types of materials, that's going to save you, and that's going to allow you to make one injection mold, but yet make two different parts out of it. And by taking an injection mold and making multiple different parts inside that one injection mold, that's called a family mold. And that is going to save you some time too, because if the injection molding company tries to sell you like 2 or 3 different injection molds, well, they're not really thinking in your best interest. And that's going to take a fair amount of time to make all those different injection molds. So to answer your question, 7 days is kind of aggressive. I would be shooting for more 21 to 30 days to make an injection mold. And that's because we know what we're doing, and it's the same process over and over. Design the mold, order the parts, CNC, fit it together, rework it a little bit. If it doesn't work, then we keep reworking it until it does work. And at that point, we're going to make what we call a first article inspection, FAI, or a T0, a trial 0 or a trial 1. That's where we shoot the plastic inside the injection mold. We open it up, we take a look at that plastic, and then we evaluate that plastic. Does that trial 0, does that fit what you need to have made? Now, inside the T0, we'll probably talk about that in a minute. Then there's texture and color, Jay, so come back to me on that. But you asked me, how long does it take? Typically, it takes 30 days to make a mold overseas, and then it takes another week to make the plastic and get it shipped to you. So you're looking at 35 days moving forward. And if you want to move it forward quicker, we can move it forward quicker. It costs more money, but it's not always a guarantee. And just because you pay more, you're not going to get double the amount of speed or the quickness back. Got it.
Well, I think everything makes sense. I'm ready. The last thing I want to talk about is this color. You know, this is definitely an interesting color. It's gold, but also there's some silk screening on there. Do you see that?
Yes, definitely.
Some like high, medium, low on there.
Definitely.
And then I have another part here we could talk about.
Sure.
You see those metal insert thingies?
Absolutely. I have some of those
over here. I know these are all post-processing steps, right?
Yeah, exactly. So what I want to talk about before we go into this post-processing is going from a first article inspection or a trial 1 or going into a trial 2, we're going to make the plastic. So I'm not sure what version this is, but I have some plastic here. And it came out of the mold, and a trial 0, it basically gets the size. Like, is this the correct size? Does this fit correctly with what you're trying to do? And if that is the case, then yeah, we can go ahead and add the texture onto the outside of the plastic part. So we'd go into the cavity and we would kind of bead blast, or it depends on the type of finish, we would add a finish to the inside of the cavity. And once we add that finish, if we have to make a change to the mold, well, then trying to make those two surface textures match up is really, really difficult to do. So we try to get the trial 0. Once you get approval on this, then we can add texture to it. And then adding a color is as simple as changing the different color of the different material, the different plastic going in there. So that would typically be a trial 1, maybe a trial 2. And then once we know that, hey, that is good, we'll go ahead and just start injection molding those all day long. And the plastic, it takes anywhere from, say, 20 seconds to come out of a mold to, depends on the size, like 3 minutes for a mold to open and close. And then that plastic will drop down. Boom, hot diggity, there it is. We have the plastic. Now it's time to add what you're just showing me, some sort of plating or colorant or silkscreen. So what would we do there? Typically, what we try to do is, if you're going to do a gold piece, we want, depending on what we're trying to do, we would try to make the plastic out of gold. So we'd shoot the plastic in gold, and then we would do the gold plating, or if we're going to put paint on the outside, we would try to make it the same color or similar colors. But it depends on what your goal is for that plastic part. We would take the plastic, we would actually send it to a plating factory. The plating factory would send along work instructions to them. So we package it all up, ship it all out, get it all back, and then we really have to take a look at the plating to make sure that it doesn't flake off, to make sure that it all looks uniform and good. And then as far as the silk screen or, say, pad printing that you just showed, we can then take and send it to a factory to have a silk screen or a logo added to the outside. And that's pretty simple. It's kind of like they take follow me on this, all right? You have a table, and there are a couple of little cavities in this table. Let's say this is a white color. They'll take a little boob, a little silicone boob. They'll touch it. They'll pick up the paint. So the paint is on here. It'll slide over to your part. It'll come down and it'll place a stamp or whatever was, if it was a picture, if it was text, if it was a little logo, it would transfer it. So that pad printing then comes down, touches the paint again, and then it comes back over to your piece, and then it basically transfers the paint back and forth. But that's how you're able to post-process and add different text onto different parts. And now,
the injection molder,
yes,
the injection molder isn't necessarily the same person that will do the post-processing.
You got it. Yeah. So keep in mind, they're different machines, right? And so different machines might indicate different factories. So some factories might own a pad printing machine, but the machines to do the plating is completely different. Or, add painting. Paint booth is completely different than an injection molding booth or anything like that, right? So sometimes yes, and sometimes no. And oftentimes, we don't kind of burden the customer by telling them, yeah, we're working with 5 factories to get your part made. But if the customer really needs to know, then we're forthcoming and we let them know, like, hey, I've got to send it to the plating company. Then after that, it goes to the pad printing company. And then after that, it goes to the, XYZ company that does this, depending on what your project is. So every company has kind of their specialty, but full turnkey is tell me what you need to have made and I'll have everything made for you. And that's something that we do, is we do that full turnkey at our company at Jaycon Systems.
Nice. And can you touch on the insert? Like,
yes.
How does that happen?
So I have before me, it's probably really difficult to see. Give me something. All right. So right inside here, it's threads. And you probably know that those threads it's probably hard to see. It's metal inside there. It's a little bronze gold color looking. And there are multiple different ways to put the threaded metal insert into plastic. So number one, I have seen where at the factory, we have hands, the mold opens up, you put it in, and the mold closes and plastic squirts around it. Like, wow, okay, so you would think that everything's just so automated, but if you're only doing 1,000 pieces, to design jigs and robots and fixtures to go together to hold your plastic in, it's very unlikely. So that's one method to do it. Another method is kind of post-processing. So you have your plastic made, we'll create a fixture, we'll set it in the fixture, and then there are machines that will actually pick up the threaded metal inserts, and it basically a couple of different methods for putting it in. One, they could use heat to basically push it down inside the plastic and kind of welds itself inside. Or they'll use what's called an ultrasonic welding machine, which will also kind of friction back and forth super fast and pushes the threaded metal insert into the machine. And then I would say, ultimately a third way would be, for example, taking manually a soldering iron, taking a threaded metal insert, putting it there, and then heating it and pushing it down inside. That's the cheapest way to do it. But at the same time, there are all different methods, and it really just depends on what you're trying to accomplish. But adding hardware into plastic, it's a little bit of an art, and we have to trial around and play around with the different tolerances to make sure that we're hitting your expectations and what it is you're trying to accomplish.
Cool. Well, I think we're running out of time. I think we can do one little last thing. The part you have in your hand, it seems like it's multicolor. How do I accomplish that? What is going on there?
Good question. So I would say that there are two different ways to do a multicolor part like this. And not only is it multicolor, but it's multiple materials. So you saw on the inside here that this is polycarbonate ABS. And then this side on the outside here, this black color, it's a TPU. It's like a rubber material. And so to do this, we would typically make two different injection molds. We'd make the first injection mold, which makes this plastic, and it squirts the plastic out. And then we could do a couple different things there. If you have the fancy machines that spin around, so it'll shoot plastic in one side, and then when it spins around the second side, it would insert the second type of plastic into the second mold. So basically, it's taking this plastic part, and it's shooting this plastic inside a different mold around the plastic. It's a little bit more expensive to do that way. We have also, and I don't like to say this, but we've actually made a mold for this plastic piece, not this specific one. And then we will manually glue it into place. But it depends on what the customer's goal is and what their expectation and what it is they're trying to do. But you could glue it, but it is a headache trying to glue some of those pieces of plastic together.
Got it. Well, Derek, I think you probably are tired of talking. I think we're definitely out of time. Really, really appreciate all the insight you gave us, Derek. We'll put your information in the bottom so people can reach out if they need some help. But other than that, thank you guys for joining, and we will get something. We'll do a similar one, but this time we'll have Derek be the customer. I'll be the PCB designer / manufacturing, and we'll go from there. So thank you guys.
I really appreciate it. Thank you for your time today.
Next week, we're going to talk about PCB design and assembly, manufacturing, all the good stuff, programming, testing. I know it's a little dry. We'll make it fun. I'm sorry. What can we do?